Guided missiles are sophisticated weapons designed to accurately hit a specific target by following a guided trajectory. They are equipped with advanced guidance systems, propulsion mechanisms, and control systems that work in tandem to ensure precise targeting and effective engagement. The mechanism of a guided missile involves several key components and processes, each playing a critical role in the missile's overall functionality. The primary components of a guided missile include the propulsion system, guidance system, control system, warhead, and the airframe. Each component is integrated into the missile to achieve its specific mission objectives. The propulsion system is responsible for propelling the missile towards its target. There are various types of propulsion systems used in guided missiles, including rocket engines and jet engines. Rocket engines, which can be either solid-fueled or liquid-fueled, generate thrust by expelling high-speed exhaust gases produced through the combustion of propellant. Solid-fueled rockets are simpler and more reliable, as the propellant is stored in a solid state and ignites upon launch. Liquid-fueled rockets, on the other hand, use liquid propellant stored in separate tanks and mixed in a combustion chamber to produce thrust. Jet engines, such as turbojets or ramjets, are used in certain types of guided missiles, particularly cruise missiles, to provide sustained propulsion during flight. The guidance system is the brain of the missile, responsible for directing it towards the target. There are several types of guidance systems used in guided missiles, including inertial guidance, GPS guidance, infrared guidance, radar guidance, and laser guidance. Inertial guidance systems use accelerometers and gyroscopes to track the missile's position, velocity, and orientation relative to its initial launch position. This information is processed by an onboard computer to calculate the missile's trajectory and make necessary adjustments to stay on course. GPS guidance systems use signals from a network of satellites to determine the missile's exact position and update its trajectory in real time. This type of guidance provides highly accurate targeting, especially over long distances. Infrared guidance systems use infrared sensors to detect the heat signatures of targets, such as the exhaust of an aircraft or the heat emitted by a vehicle. The missile's onboard computer processes the infrared data to lock onto the target and guide the missile towards it. Radar guidance systems use radar signals to detect and track targets. Active radar guidance systems have an onboard radar transmitter and receiver, allowing the missile to actively search for and lock onto targets. Semi-active radar guidance systems rely on external radar sources, such as those from the launch platform or ground stations, to illuminate the target. The missile's onboard receiver then homes in on the reflected radar signals to guide it to the target. Laser guidance systems involve illuminating the target with a laser beam, either from the missile itself or an external source. The missile is equipped with a laser seeker that detects the reflected laser energy from the target and adjusts its flight path to stay on target. The control system of a guided missile is responsible for executing the commands from the guidance system and making real-time adjustments to the missile's flight path. The control system includes actuators, servo mechanisms, and control surfaces, such as fins or canards, that adjust the missile's direction and stability. The actuators receive electronic signals from the guidance system and move the control surfaces accordingly to alter the missile's trajectory. This dynamic control allows the missile to maneuver and correct its course throughout its flight, ensuring it stays on target. The warhead is the destructive payload carried by the missile, designed to inflict damage upon reaching the target. Warheads can vary significantly in size, type, and purpose depending on the mission and target. They can be explosive, carrying high explosive materials designed to detonate on impact or proximity to the target. Fragmentation warheads contain metal fragments that are dispersed upon detonation, increasing the damage radius. Armor-piercing warheads are designed to penetrate heavily armored targets, such as tanks or bunkers, before detonating. In some cases, guided missiles can also be equipped with nuclear, chemical, or biological warheads for strategic purposes. The airframe of the missile provides the structural integrity and aerodynamic shape necessary for stable flight. It is designed to withstand the forces encountered during launch, flight, and impact. The airframe must be lightweight yet robust, often constructed from advanced materials such as composites, aluminum alloys, or titanium. The aerodynamic design of the airframe, including the shape of the nose cone and the configuration of the control surfaces, is optimized for the missile's intended flight profile and speed. The launch sequence of a guided missile begins with the activation of the propulsion system, which provides the initial thrust to propel the missile away from its launch platform. This platform can be ground-based, ship-based, or air-launched, depending on the missile type and mission requirements.
Once the missile is airborne, the guidance system takes over, processing data from its sensors and navigational instruments to determine its position and trajectory.
Throughout its flight, the guidance system continuously updates the missile's course, sending commands to the control system to make necessary adjustments. The control system's actuators move the control surfaces to alter the missile's direction, ensuring it stays on the optimal path towards the target. This process involves complex calculations and rapid adjustments to account for factors such as wind, target movement, and other environmental conditions. As the missile approaches its target, the guidance system ensures precise targeting by refining its trajectory and homing in on the target. In the case of infrared, radar, or laser-guided missiles, the guidance system locks onto the target's signature and adjusts the flight path to achieve a direct hit. For GPS or inertially guided missiles, the guidance system relies on positional data to ensure the missile reaches the designated coordinates with high accuracy. Upon reaching the target, the missile's fuse system determines the optimal point for detonation. Fuses can be contact-based, activating upon impact with the target, or proximity-based, detonating when the missile reaches a certain distance from the target. The warhead then detonates, delivering its destructive payload to the target and achieving the intended mission objective. The mechanism of a guided missile involves a highly coordinated interplay of advanced technologies and systems, each contributing to the missile's overall effectiveness and precision. From the initial launch to the final impact, every component must function flawlessly to ensure the missile successfully reaches and destroys its target. The continuous advancements in missile technology, including improvements in propulsion, guidance, control, and warhead design, have made guided missiles some of the most formidable and accurate weapons in modern military arsenals. Their ability to deliver precise and devastating strikes against a wide range of targets underscores the critical role they play in contemporary warfare and defense strategies.